Okay, guys, welcome back to another segment of the Inakustik Tour. And in a lot of respects, this could be your favorite section of the tour because it gets into the weeds of measurements and the lab. And for people that are on the fence of objective, subjective, there's certain things in cable making that are inarguable. LCR, the inductance, capacitance, resistance. Those are things that, unless you have no standards whatsoever, and it would take a lot, having zero standards and all the things I've already shown you would take a lot to not care about any of those things. But now we're going to be talking about actual capacitance, inductance, and resistance, and experiments to show you those measurements and why they do the air dielectric, and why looking at inductance only for speaker cable may not be the smart way to do it. There's a lot of dogmas that are very primitive, and why you want low capacitance in certain aspects, and what that formula, the combination of those three things, it's a much more sophisticated science than people that just say, oh, you can just use coat hangers or corroded wire or whatever. If you really believe in high-end audio and you want a high-end product in your cabling, you can buy a lot of voodoo out there, and they agree with you. And that's why they're talking today strictly on physics, metrics, measurements, and you're going to see that today. But the other takeaway, if you haven't already noticed, is that these guys are hilarious and fun, and they don't have this facade of pompousness. And they never tell people they have to buy stuff that thousands of dollars a cable for a modest system. That's why they offer stuff in all the budgets, and they acknowledge there's a lot of voodoo out there. But again, their transparency, their fun, and then brilliant as well, as you see in these experiments today. I think you'll really enjoy this. But if you didn't see the funny YouTube short I uploaded with Holger, I'm going to put that first, and then we'll get into the tour. So enjoy, guys.
Explaining cables is very easy. So if you have the wires, so you have two of them, and so due to the skin effect, it's like that. But normally you must put them on cable stands, it's like that. And but it looks a little bit strange right now, so I have to finish the drawing, which is finally like that. So maybe we talked about the cowboy, so I'm here.
I didn't know where this was going, but now I see you did a cow for the cowboy. Thank you so much, Holger. You're so talented. I see how you got your job. It looks like we're going to the lab. This is cool. Okay, put it on. Let's see how he looks.
You don't need to do it.
I've got the cowboy hat in the car. I think that would go perfect. Protect your head.
I look serious, like an engineer now.
You need to know.
The straight jacket is better. Yes. Yes, this is a big improvement.
Take it off, no problem.
No, they don't believe us that we're German, because there's a saying Germans don't have any humor.
Oh, no, that's not true here.
Made in Germany, those guys are making fun of each other.
Maybe we start over there, because you hear this noise.
Yes, what is that?
The braiding machine.
Oh, okay, let's watch that,
so,
yes.
So I can show you the braiding machine. It's
Okay.
a little bit noisy inside.
That's okay.
We'll switch it off later on, so we have no.
Yeah, let's go ahead and see it.
So this is the braiding machine. It looks very historical, and it has a history behind it. Because when we start this particular series of cable, we make this raw material in our cable factory, but we don't have the opportunity to make a braiding on it in the beginning. So we ask a company who is making this climbing ropes. And they say, yes, no problem, we can do the braiding on it. And a couple of years we gave them the order to make the braiding on the cable. One day they asked us if we want to purchase this machine, because it's only used for our cables, and they need the space. And yes, I said, okay, let's buy the machine and do it by ourselves. And since
self-sufficient,
8 or 10 years or something, we do it by ourselves.
So how many machines did you count that you made Dieter to buy for you?
Wow.
During your career?
I could convince him for many machines. Yeah. Yeah, but he's willing to invest, so that's all okay.
Well, this again separates you from so many who just buy the jacketing, the braiding. You're actually creating something that's unique, nobody else will have, and distinguish you.
Yeah.
Which again, pride of ownership and aesthetics are part of any purchasing decision nowadays. So yeah, this is, and you're self-sufficient now. You can make this yourself.
Yeah.
Cool.
But
Also
it's
means we can do smaller individual productions for dealers or for customers who say I want to have my own cable and market it, and we can produce.
Okay, that's interesting. Yeah.
Because we also produce for others in the market.
Because you have the capabilities they don't have. Yeah.
And I assume they ask the companies that know what they're talking about to produce cables for them. So it's also a good thing for us that we do that.
Here's some. These are some awards you had here. Yeah. Okay.
It's a very old poster.
Yes.
Also back then we had like German press awards and.
Cool.
Yeah.
okay. I think we go into the mechanics now.
Yep. The lab.
This is more for all the mechanics things we have to do, like also toolings, prototyping, and we have also a series which is called ambient track. It's a trunking system for cables and power sockets and these things.
And
I have to do it by
no. what people don't know, Holger is also our janitor. In part-time he works as janitor.
Well, facility manager. That's me, yeah. That's great. Yeah, but it's really.
I need that jacket.
Yeah, but sometimes it's necessary because it's mechanical. And
With a cowboy hat, you're gonna look like a pretty shady character. Yeah. Okay.
I'm gonna get the hat.
Yeah. So what we do here, so it's all mechanical stuff, and this, for example, is a CNC milling machine. Also computerized, and so we can do toolings. You see here this is an example of the ambient track trunking system. It's not cleaned up right now, but anyway. So we make all the millings here inside. Also the molding toolings you saw before. We do also make also here with the milling machine, yeah, so depending on what we are doing, we have the sandblasting unit here. So if you make them
He's got the. Oh yeah. Let's see the look.
So okay.
You got to put on the coat now.
Okay.
Is it too big?
Okay. But now I need a hose. Maybe if you just take from here, I can do like that.
It's gonna be the best, the most watched part, or the least watched part. Everybody's gonna tune out or love it. Somebody's gonna give me a super thanks. Give me $5 for that. So this is the sandblasting machine.
Yeah. So if you make the molding tooling, we need a particular surface, of course, so that we have a good surface on the molding. So we make the sandblasting here. And yeah, here we have some more opportunities to make all the cuttings and drillings and everything.
But you've got so many tools. I mean, thinking of cables, people think it's so easy to manufacture, but look at all the tools and investment that is needed, from quality control to assembly, jacketing, everything, and just clean, everything. Impressive.
You must have a clean working place to develop and produce good products. This is part of an old laboratory with some old stuff here. So the times when we had more topics with HDMI, we have the opportunity to make several tests here, several combinations. In the meantime, we have a small HDMI testing equipment. It's in the opposite side of the building for make quick tests, also for 4 and 8K applications. But this is the old part of the laboratory. We did all this HDMI testing.
Well, when I told Sven I could beat him at tennis, I was talking about the PlayStation. We bet big money, so I think I'm going to win.
Yeah, so now we go to the laboratory, small laboratory. Let's say nothing special, but we can do most of the things we need to do by ourselves. So starts with some transformers for insulation. So if we make tests with a power station, so that for safety reasons we have that one. So if the unit is open and we do some measurements inside, we must have what is the wording for it? Trenntransformator.
It's technical German.
It's
I don't
technical
even
German.
understand
So
what it is.
it's not connected to the mains, so
Okay.
it's disconnected.
Let's just look at this word. How many letters are in this word here? Come on. How many syllables is that? So how do you say that? Can you?
You know, I can't count. One, too many. That's
Too
all
many.
I can do.
Okay. But how do you pronounce that in German?
Labor-Trennstelltransformator.
Oh my goodness.
Yeah,
Okay,
you
that's a
just
first.
without the voltage anyway.
Okay.
Okay, so so we have a function generator, power source, scope with spectrum analyzer built in, and so we can make some tests here. Very technical. I remember when we talked about to make to show somehow the differences of cables, and we have something which I show very often is to explain the air insulation. You know?
Okay, yeah.
The
Why you do that air
why we do
insulation?
that.
Yes.
So first of all, why do we need an insulation of a cable? Why are all the cables insulated? It's very easy. That's to avoid a short circuit and to avoid that you get an electric shock.
Right.
That are the main reasons. There are some more like to protect the wires inside against oxidation and these things, or mechanical forces and these things. But mainly it's to protect the circuit for a short circuit and electric shock. So for interconnect cables or for speaker cable, there's no risk of electric shock. There's also the main thing is the short circuit. So that means, if possible, we should avoid the insulation material. And the best insulation material you can use is air. So why? All the plastic material stores electrical energy. It's like if you have some clothes with some synthetic parts inside, you take off the clothes, you feel.
Please don't.
Yeah.
I did it before. You see it.
My video will get banned.
but I stopped at the right time.
Okay.
Yes. But if you do that, you hear this crispy sound, and if it's dark, you see also the flashing. So this is electricity. So all the plastic parts inside the clothes also store electrical energy, and you can imagine this audio signal. It's very sensitive. It contains all the information, all the frequencies, all the phase shift, and everything is inside this audio signal. And if you have some plastic material who stores this electrical information, it will take off something from the signal, and that we want to avoid. To show how it acts, we have this dummy. So if you look in, we have two copper strands inside. These are copper tubes, but anyway, the basic style is similar. And we have this plastic parts inside. And what I would like to do is I will measure the capacitance.
Okay.
The capacitance indicates how many electrical energy is stored in this structure. So I take this.
And again, when we're talking about capacitance, inductance, resistance, those are the three key measurement points for cable and transmissions of cables that almost nobody denies. You know, we're not talking about voodoo stuff right now. This is stuff that is generally accepted, you know, in terms of physics, even the most objectivist would acknowledge that capacitance in cables is a factor.
Okay, you're right. That's great. So let's have a look here. I will connect it to the wires, and so you see here the capacitance of this structure now is about 80.6 picofarad. Farad is the what is it, the value which is used for the capacitance. So this is the structure like it is now. Next step I'd like to do is I will remove these plastic parts and then
Measure
look
it.
what's going on with the capacitance. So put it in here.
Holger is doing a lot of work.
You are working. I'm really impressed.
This is for a Monday. Y'all are really doing a lot. Thank you, sir. That's why we're having to film it, because it's the only time it's ever happened.
But that's the only thing he can do. Just okay, so once again, measuring the capacitance of the cable, or of this structure. It's not a cable, it's a dummy, like a cable. Looks a bit like a standard speaker cable.
Wow.
And you see what's happened.
Yeah.
Now we're coming from around 8 picofarad, 32 picofarad.
Yeah.
So just by taking away the insulation material. Now, remember the interconnect cable, for example, the NF2404, which has a huge diameter compared to standard wires. It's not to let the cable look more impressive. It also has some physical backgrounds, and that I would like to simulate here as well. So I'm increasing the distance here of these both conductors. So now we have a structure which looks similar like of the interconnect NF2404. Again, start measuring the capacitance. So.
Wow. That's incredible.
That's incredible. So starting with the 80.
Yep, all the way down to 80. Just taking out the insulation material, using air, and then spacing properly. This is showing why you do it. And the key point that you made a second ago, so many companies make super wide cable, jacket, but when you cross-section cut it, it's just a couple of conductors or maybe a few, but they're packed in there, and it's all insulation that makes it look impressive. I've even seen dealers and people in the industry fooled by that impressive metric that's on the outside, but there's a reason why. If your cables are thick, it's because that length, that type of application, this is the capacitance you were shooting for. And this is very impressive demonstration. I'm glad you were able to, again, show it with measurements.
Yeah, that's how we work, yeah, sure.
And
based on physics.
Capacitance is very important, especially if you have long runs of cable. That is something people need to factor into the equation. If you have long runs of the capacitance, if you don't have a low capacitance cable, it's even more important if you have long runs. But this allows you, if you do have a long run cable, Inakustik is the brand, obviously, one to definitely consider because they pay attention to minimizing that. Can you explain just generally for a layperson example, capacitance, this is an electrical term, is what it is, like inductance and capacitance?
Yeah, so like mentioned, so it's the capacitance acts like a battery, let's say. So the capacitance on a cable. So a cable has to be charged before it is able to transmit a current. So that means the output stage of an preamplifier, or also the output stage of an amplifier, has in advance has to deliver some current to charge the cable. So therefore you have a delay on it. And on sources, for example, like a streaming player, which has a very weak output stage, which does not deliver a lot of power, it has to charge the cable. And that's one important point many people do not know. Also on a speaker cable, you know you have this polarity, plus and minus, but we always talking about alternating current, so which always change the polarity. That means the output stage has to charge, discharge, charge in the reverse, and discharge in the reverse. Also the capacitance of the cable, and that needs power. That is deforming the signal. It's deforming all the audio information. That's why the cable should have, in the best case, should have no capacitance. But that's not possible. So all structure with some metal units or metal parts inside always has a capacitance. But it's wise and it's necessary to have cables with a low capacitance.
Mm-hmm.
As you mentioned, for the interconnect cables, the output stages they are weak, not enough power to discharge the cable all the time. Also for turntables, the cartridges, they really deliver just a really tiny energy. And for those cables, it's also important that for those systems, it's important that the cable really has a low capacitance. And I really can recommend also for that application using good cable, air-insulated cables, to don't have any trouble with that.
Yeah, I've seen it.
Quality.
I've seen it firsthand with even passive preamps that don't have a buffered output stage like you're talking about. If you make that a long run, you are going to hear the difference if it's a high capacitance cable. Yeah, a lot of problems. That will be audible. Anybody that claims it's not audible must be deaf, because that is from science. This is actually can be proven with measurements and taking measurements before and after with that kind of cable. So if you do have unfriendly impedances between gear, and we're talking about interconnects and phono cables, you're going to want a cable that considers capacitance and minimizes it. Now sometimes we'll probably get the speaker cables and inductance, that's another factor. But yeah, this is a great, at least focus on capacitance.
Yeah, but yes, so for a speaker cable, you mentioned these three parts. So capacitance, resistance, and inductance of a cable. These are the main things we have to focus on, and depending on the applications. So we can't take them away. We just can play with them. So we can build cables with a lower, let's say, resistance, but at that time we automatically increase for example, the capacitance. Or if you want to reduce the capacitance, in normal circumstances we increase the inductance of a cable. So it's always
balancing out.
So
right.
The trick is, and let's say somehow the secret is to find the right balance of both. And for speaker cable, sure, the resistance is important and the inductance is important, more important than the capacitance.
Mm-hmm.
To really have a cable which delivers the full sound, all the frequency, has a linearity so that this not influences the sound. But the capacitance is also important on speaker cables, because if you have a closer look to the power amplifier, all the power amplifiers have a feedback inside which takes control of the output. So it always compares the output to the input, and if there is a difference between, it's automatically adjusting everything. And if you have a capacitance on the output of the amplifier, it takes influences on the feedback. And so there's some delay on the feedback. And so that means that the distortion of the amplifier is changing. In that case, power amplifier and speaker, it's not the transmission which is affected, it's the sound quality of the power amplifier which is affected by the cable. So the power amplifier is changing his quality, so and the purity of the sound. That's what happens with a high capacitance on a speaker cable. High inductance on the speaker cable is similar than high capacitance on interconnect cable, so you're missing some high frequency, so it's damaging the sound, the transmission. Yeah, and resistance, of course, you need a low resistance on the speaker cable, because they have high currents, especially on high power levels. Powerful sound. If you have bigger speakers with bigger woofers inside, you have high currents, and you need some, of course, some low resistance on that.
Yeah, so correct me if I'm wrong. I mean, this is important to know. Number one is that a company that is using objective metrics that are established, resistance, capacitance, inductance, and then choosing the right balance for the application, whether it's an interconnect or speaker cable or power cable, which has another priority. But in the case of a speaker cable, you know, high capacitance, the reason why you don't always want to go with these companies saying low inductance, the best low inductance they can find, because a long run of high capacitance speaker cable can cause problems. I had to deal with this helping a friend with over 60-foot run. You know, that's something you need to start factoring in, the capacitance. So again, don't fall for primitive, you know, generalizations about inductance for speaker cable only, look at only that, look at only capacitance for interconnect, or resistance for power cable. It's a balancing act, like you have studied and used metrics. And again, we're talking about things that are measurable.
Yeah, and right now we talk just about the basics, so the physical basics. There are so many more details, like the purity of the material we are using, like the structure of the wire themselves. So we have also things like a skin effect. You may heard about that.
It's controversial, but yeah, I'd like you to give a take on that as well. Yeah.
Yeah. So maybe I will show you later on the
yes, let's do that.
Of the wire of the conductor we are using in the air cables, which are really a particular style.
Okay.
To avoid eddy currents, to avoid skin effects and all the things. To have a linear working cable and cable which gives you the full sound, and so that you don't.
And you have an explanation for those that say these eddy currents and skin effect aren't really applicable to the audio side. You've actually been able to diagnose some scenarios where that is actually something that is applicable. You know.
Yeah. So. Holger is good. Yeah. What did you?
That was me last week.
Last week it said Holger is great, so I don't know. What did you do?
So anyway, let's do it anyway. So maybe I can show you a little bit about the skin effect. So
okay.
I didn't hear about that. If we have hopefully I can draw. So since I'm working on the computer, it's not.
You should be tired by now.
I have to be careful what you draw now. Okay, so if we have a wire like that, so this is just a conductor. So just a conductor. So we have a cross section, and so this is the cross section, which is what is it? AWG, is it in the US?
Gauge.
Gauge.
Yeah.
Gauge, exactly. The gauge. So this is the full size, and if we have make a small drawing here. So if we have so this is the time, and this is the level. So if we have DC current, which is like that. So there's no frequency on it, just a current in one direction. So this kind of current can use the whole cross section, no problem at that. So if we take the green color, if we take some alternating current, which is changing the direction, you remember analog audio signals always have alternating currents, so changing the polarity. So, for example, like a sinus curve is like that. So, it's changing the polarity plus and minus. So the direction also changes on the wire all the time. And if we have a higher frequency, so due to some eddy currents inside the wire and some magnetic fields which are surrounding the wire, we have this so-called skin effect. So the wire is, or the current is not able to use the center of the wire anymore. That means on higher frequencies, like that, the cross-section is limited.
More dense.
So like that. So it's like a tube, you know.
Right.
It's just able to use part of the cross section. And if we increase the frequency again, hopefully, oh, that's not so very good. Anyway, so we are losing some more of the cross section because the current is shifted more and more to the skin of the wire. That's why it's called a skin effect. So the cross section is suffering, not physical, but the part the current can use becomes smaller and smaller. So
the low frequencies are using more of the center of the conductor, pushing the higher frequencies out further.
Exactly.
Okay.
So low frequency can use the whole cross section. High frequency just the skin of the cross section.
Okay.
And that means we have a difference between the cross sections for low frequencies and for high frequencies. That means for low frequency we have a lower resistance, and for high frequency we have a higher resistance. And therefore this wire will not act neutral. So it's really damaging the sound. That's the skin effect.
Gotcha.
Sorry for the bad.
Yeah, but this is good to kind of give a layperson's example that when you get a low frequency information going through the cable, all of a sudden it could impact other things. And this is general transmission line. Now, whether it affects dramatically or whatnot, again, you want a cable company that at least understands this and does everything possible to minimize this. And I guess we'll show that in more detail as we go. But yeah, I appreciate you going into this level of detail for me. Maybe not for everybody taste, but those that really are into the nerdy side, this is really good stuff. So thank you.